Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. We finished 3 consecutive sessions of finding volumes of solids of revolution using the method of disks, the method of washers, and the method of shells. And then I told you that I will share with you something that I believe you will like. It's called Pappus Theorem. Pappus was a Greek mathematician living in Alexandria in Egypt, where I came from, but that has nothing to do with anything. Pappus theorem is a very powerful theorem that if you have 2 pieces of information out of 3, you can get the third using that theorem. But what are these 2 pieces of information? Well, the 3 pieces are the area of a shape, its center or its centroid or center of area, and it's not, it is, and its volume of revolution. What does that mean? If you give me any 2 of these, I can find the third. Let me show you something very simple. Suppose this is my X and Y, so let me draw very simple, just a triangle. And I have a triangle of base B and H and height H. Excuse me. So I know the area of the shape is 1/2 B times H. If you remember, or if you have checked the centroids or centroids of shapes in the statics course in Engineering Made Easy, you have learned that the centroid of a triangle is at 1/3 of the base from the right angle. So this is B over 3, and this is 2B over 3. Okay, and this is H over 3 and 2H over 3. So 1/3 B. So Pappus theorem says, if you know the area of a shape and you know the location of its centroid, then rotating that, say, about the y-axis gives you a volume, right? So the volume in this case equals the area that generated. Notice that the volume would be what? If you said a cone, you would be correct. You will get a cone that looks something like that. And we know the volume of the cone is 1/3 the area of the base. Notice the base here is a circle of radius B, right? So pi B square times H. That's the volume, right? 1/3 pi B square H. Alrighty. So what Pappus is saying is, if you know the area that generated that volume, which is what is the area that generated the cone when we rotated that 1 full turn about the y-axis, it's a triangle. So if you know the area that generated the volume and the distance the centroid traveled in doing so, in finding the volume, then the volume would be the product of these 2 things. Wait a second. The area that generated the volume is 1/2 BH, right? And the centroid is here. So when I rotated this triangle 1 full turn about the y-axis, the centroid traced a circle whose radius is b over 3, correct? And the distance traveled is the perimeter of a circle whose radius is b over 3. The circumference of a circle is 2 pi r. 2 pi, and r here is b over 3. Now, 2 and 2 cancel, and you get 1/3 pi b square h. Isn't it nice? In other words, if I know the volume of the cone, and most of us know it, and I know the area of a triangle, I will divide the volume by the area, and it will give me the distance traveled by the centroid. The distance is always going to be 2 pi times the radius. The radius is the centroid, so I can get the centroid. If I know the volume and the centroid, I can find the area that generated it by dividing the volume by the distance traveled by the centroid. So knowing two of them will give you the third. Now, and you say, okay, nice. Here I'm going to show you something, and then in the next session, we'll do like the second part of the theorem. Remember when we did the centroid, I told you that if I have a shape which we call the rectangle, right? So let me just do the rectangle, and then a triangle, and then a second degree parabola, and then a third degree parabola, and so on and so forth. So this is, so when I look at this line, so I have a right angle here, and then I'm going to describe that thing. That thing is a straight line, right? A constant line. Meaning, if I want to represent y as a function of x, it's constant. Meaning, it's something times x to the 0th power, right? It's just constant, b. So b times x to the 0 is b. So here I'm going to say n, which is the power, is 0. For a triangle, this is a straight line, right? So you say y equals b, bx plus c, or whatever, or mx plus c. So it's x is to the first power. Second degree parabola means 2. Third degree parabola means 3. So when you calculate the area, you multiply b times h, the base times the height, the base times the height, the base times the height, and then you divide by n plus 1. So if it's a rectangle, you divide b times h over 0 plus 1, meaning b times h over 1, which is bh. It's a triangle, you multiply bh over 2. I'm sorry. bh over 3, bh over 4, and so on and so forth. Nice? Okay. The x bar, which is the distance of the centroid, assuming this is the origin, that distance, x bar, would be b over n plus 2. So if it's a rectangle, n is 0, so that becomes b over 2. If it's a triangle, it's b over 3. If it's a second degree parabola, it's b over 4. If it's a third degree parabola, it's b over 5. Amazing. So easy, right? The y bar, so this is x bar, this is y bar. The y bar, it's a little tricky. It's h plus 1 over 4h plus 2. Now, I'm sorry, over, what am I saying? Times h. This is n, not h. Why did I say h? N plus 1 over 4n plus 2. So if n is 0, you get 1/2 h over 2. Of course, it's the centroid of a rectangle. For a triangle, it's the same thing. N is 1, so you get 2 over 6, or 1/3, h over 3. So for the triangle, the x bar and the y bar are the same. But for the second and third and any higher degree parabola, you say n plus 1 is 3 over 4n, 8 plus 2, 10. So 3/10 h. If it's a third degree parabola, you say 3 plus 1 is 4. 3 times 4 is 12 plus 2, 14. 4 over 14 is 2/7 h, and so on and so forth. And you say, why are you telling that? I'll tell you now. The problem I want you to solve is to find the volume of rotating the following shape about the y-axis. Well, we can do the x or the y, it doesn't matter, it's the same idea. And that shape is a little tricky. I'll let you think about it for a second, and then we'll do it. It's a third degree parabola, like this guy, but it's backwards, meaning it's not going like that, it's going like that. This is a cubic, third degree cubic function. And B and H can be anything because really it doesn't matter where you start. So let's say because that can be any constant times B cubed. So for example, we can say this is 5 and this is 3, for example. I'm going to rotate this shape, and that's a third degree parabola about the y-axis, and I want to find the volume generated. Here's the information. Pause the video, try it on your own, and let's come back. Now, I know that the area here of a third degree parabola is BH over 4. So area equals 3 times 5 over 4 equals 3.75 square units, or 15/4. It doesn't matter. I can leave it as 15/4. But where is the centroid? Please don't say B over 5. Because B over 5 is from the right angle, meaning it's B over 5 from here. This is 1/5 of the base, or 1. But from here, it's 4 units from the y-axis. Do you understand what I'm saying? If that was drawn like that, I would say yes, the centroid is at distance of 1. But if I draw it backwards, it's like if this triangle is backwards, the centroid would be at 2/3 of the base. If it's like that, the centroid would be 1/3 of here and 2/3 of there. Same idea, 1/5, 4/5. 4/5 of 5 is 4. So the volume generated would be 3 times 5 over 4, that's the area, and the distance traveled would be 2 pi times r, which is 4. 8 pi. The 4 and the 4 cancel. 2 times 5 is 10, times 3 is 30. You get 30 pi cubic units. See how easy it is now to do it? And so if we can find an equation here, so you can say y equals something times x cubed. X cubed is 125, but this is only 3. So 3 over 125 x cubed. This is the function y. And let's say I want to find the volume generated using calculus of rotating this about the y-axis. We can use the method of shells. The shells method would be much easier than the method of washers, right? Because I don't need to subtract anything. So I'm going to take a piece like that. The height is 3 over 125 x cubed, right? Notice times dx, that's this shape. But when I rotated that about the y-axis, I will get 2 pi times 4. In fact, not times 4, times x, right? Times x, because every piece is x away from the y-axis. If I integrate that from 0 to 5, I should get the volume. Now, I get 6 over 125 pi, 2 times 3 over 125, times x to the 4 over 4 from 0 to 5, right? Integrating, oh, I'm sorry, x to the 5 over 5. There's an x here. Sorry. Okay, so when I do that, I get 6 pi times 5 to the 5th over 125, which is 5 cubed, times 5 is 5 to the 4th, right? 5 to the 5th divided by 5 to the 4th is 5. And 5 times 6 is 30, and 30 times pi is 30 pi cubic units. Same answer as before. Much faster, doesn't require integration, but the key here is that you know the area and the location of the centroid. If you know these two pieces, you can find the volume either about the x or about the y. About, if I rotate about the x, the height is at 2/7 h. H is 3, 2/7 is 6/7, right? So you multiply 6/7 times 2 pi times the area, which is 15/4. You will get the volume if I rotate about the x, not about the y. I hope this was an easy one. Next session, we'll do something more about Pappus Theorem. And until then, I wish you all the best and hope to see you soon. Bye.